began with something known as nanotechnology. Now, I started with nanotech in healthcare, but over the past month, I've read hundreds of research papers almost every single night about counterfeit products and nanotech. Now, it all actually started because I am pretty much obsessed with Jordans. I love my Jordans, I love my basketball shoes. In fact, I'm wearing them right now. Now, these up here are Jordan Retro 4s. I really want these shoes. They're roughly $300. So my mom, she's pretty iffy about letting me get them. But the other day, I saw these shoes for just $70. My eyes went wide. I became so excited. I was like, Mom, I found the shoes. But I go on the website, and they honestly look really weird. The logo, it's in the wrong space. The laces look weird, and the color is completely faded. That's when I realized these shoes are fake. No, I never thought these were actually real. So I decided to play a game with myself. I was like, okay, let me see if I can tell what shoes are real and which ones are fake. So I want to play the game with you guys. Which one do you guys think is fake? Just shout out the answer. B. All right, we got a very smart audience. You guys are correct. So B is actually fake. Now, the thing is that counterfeit products have been reaching an epidemic level. For me personally, if I got the shoes, it wouldn't make a huge impact on my life. I mean, they're just shoes. But this happens in everyday items, like access cards, credit cards, laptops, AirPods, anything you can think of can be counterfeit. Now these counterfeiters, they are pretty smart. They have 500 identity frauds every single day. We are currently losing $200 billion in fake pills. And we're losing $461 billion in the total counterfeit market every single year. Now, you might think, okay, how big is this number? We're basically losing half of Tesla's network every single year. Now, like I mentioned, these counterfeiters, they are pretty smart. What essentially they do is they analyze a product, they recreate it, and then they mass produce it. Now, a lot of the current solutions, they can easily be reverse engineered. But if we can use the properties of the nano scale, we can make all of these products look different on a nano level. Now you're probably like, okay, Pavi, wait, what in the world is a nano level and what is a nanoscale? Okay, I want you to think of it like this. Look around in this room. We have roughly like 300 people here. Now if I had to put everyone in a car, how many cars do you think I would need? Sir in the green shirt, how many cars do you think we would need? A little bit of quick math for 300 people. You're right, 60 cars. So if we needed 60 cars for this many people, what about how many cars would we need for 8 billion people, so the entire planet? That's a little bit of a harder math equation. Now, if every person on this planet was the size of 1 nanometer, we would only need 1 car. Oh, did I mention it's a Hot Wheels car? So boom, you can see nanotech is everything at the atomic level. It's everything really, really tiny. Now, if we can actually identify products with an atomic level, we'd be able to see how different every product is at the nano level. Now, we can actually do this with something known as physically unclonable functions, or PUFs. These PUFs are basically these really small chips. We can implant these PUFs into basically any product. And what counterfeiters would have to do is they would have to copy billions and trillions of atoms, a specific atomic configuration. But with the strongest microscope, the most advanced computer, they would not actually be able to do this. So counterfeiters, they cannot copy trillions of atoms. Now you're like, okay, I remember 6th grade science class. I know atoms are small and I know atomic configurations, they seem pretty difficult. But you're probably like, how hard is it to copy trillions of atoms? Think of it like this. Let's say I had 2 buckets of sand. I'm going to give you guys a little bit of a challenge. I take 1 bucket of sand and I dump it on the floor. I say, okay, here is configuration A. And just to make it a little bit hard for you guys, I'm going to step on the sand. Now, the challenge is, I have another bucket of sand. I dump it on the right side, and I say, I want you to make configuration B look just like configuration A. Now you're all looking at me like, okay, this isn't too hard. Now, I'm going to make the challenge a little bit more difficult for you. I'll give you 1 full week. But I want you to make everything in configuration B look everything identical to configuration A, but every grain of sand has to be identical. Okay, now you guys are looking at me like I'm a little bit crazy. And that's exactly what I mean. Let's say a week later, you guys come back to me, and you provide me with this. You know, if I tilt my head a bit, I squint my eyes, okay, yeah, they're similar. They're somewhat the same, but they are not identical. Every grain of sand is different. Every grain of sand is in a different spot. That's exactly what happens on the atomic level. No atom is the same. No atom is going to be in the same spot. That's exactly what I mean. Attackers cannot copy trillions of atoms. Essentially, the process is, we start by creating this PUF, this quantum ID. We can integrate it into literally any product, and then you can authenticate it with a smartphone. Now you're probably like, okay, wait, Pavi, how did we go from atoms to figuring out if a product is counterfeit with a smartphone? Like, wait, what? Essentially how it works is every single quantum material is made of atoms. We all know every 2D nanomaterial has an atom. I want you to hypothetically picture a rectangle. This rectangle is our 2D nanomaterial. We have atoms everywhere. However, we also have impurities. These atoms can be in different places or just be wrong overall. So let's say in our hypothetical sheet, we have impurities 1, 2, and 3. So here we have 3 impurities. Now, these impurities emit light back to you when you shine light on them. So when I were to shine light on that hypothetical 2D nanomaterial, I would be getting 3 lights back in these 3 spots. Then what you can do, take that, basically crush it, and put it onto a PUF, that little mini chip I was talking about. Now, if it's on that chip, if I were to take a flashlight and shine it onto that PUF, it'll re-emit back the same light. It'll re-emit back 1, 2, and 3. That's how I can tell if a product is not counterfeit. Now, if it didn't re-emit back the same lights, then it would be counterfeit. Essentially, here is TMD. This is a 2D nanomaterial. This is what I mean. These are impurities, and they're like emitting back different light. So if we can harness this, put it onto a PUF, we'd be able to extract this. And the thing is, it's just a little bit more complicated. In fact, it kind of looks more like that. Now here we have TMD. The first step is you have an optical lens, or an OL. This OL is basically going to extract all of those impurities and all the light. From there, it's brought onto a rotatable bandpass filter, or a BPF. This BPF is going to look at those wavelengths of those photons and extract the angle and the bandwidth. Keep those in mind. After that, it transmits this onto a CCD, basically just a ton of pixels. So here, those red spots are basically the different bandpass filters. When you change the angle, you get a different subset of pixels that are re-emitted. These pixels are different energy levels. So, if we could actually put these on the PUFs, we would create an unclonable solution. So basically, we have our angle, we have our bandwidth, and we have those lights that are re-emitted back to us. And boom, you have created your own PUF. These PUFs are integrated into literally everything, and with just your smartphone, you can tell if something is counterfeit or not. Now, with these nanoscale PUFs, counterfeit solutions will not reach an epidemic level. Thank you so much.
Wow, not gonna lie, that was one heck of a presentation. Let's give another hand for Pavi. Thank you so much. Okay, wait, Pavi, before you move on, I would like to say that if you want to grab cake, you better go grab it, because my sister's emailed it very so clearly. I noted that.